Welcome back to episode 9 everyone, and we're now moving into part 3 where we're going to look at some other common window functions. So let's head on in to SQL Server Management Studio. Alright then, let's change that database and we'll have a look at rank and the dense rank window functions. Now to type them out is pretty much exactly the same as the row number, as you can see here. One is the rank and one is the dense underscore rank there, both of which end with double brackets, open close there, like all functions pretty much start and end with a bracket there, but we don't pass any parameters into it, which is why it's blank there. And like the row number, it returns a big N, so we're getting whole numbers from there. Same again over, and we're going to then open brackets, we're going to partition by the customer ID and order by the sum of the extended price. Pretty much exactly the same code that we've seen before when we're doing the row number. So that's the rank, and then of course we have the dense rank underneath it, partitioned and ordered by in exactly the same manner. We're only looking at 2015 and we have got the customer ID equals 1 in that. So let's have a look at the values and we'll see what's going on. So first thing you'll notice is it looks pretty much similar to our row number, where we get numbers ascending from the lowest extended price up to the highest. There we've got 40 rows there. But one thing you'll notice here with our rank function is these two values are exactly the same. So when it comes to ranking, they are grouped together. So after 1 we've got 2, so these are both put into a rank of 2. Now with the rank function, once it moves on to the next value, it will then skip the 3 and go straight on to 4. That is because there's 2 numbers for number 2. So instead of a 3 there and then going on to 4, these are both the same value, so they're ranked as 2. Now if these 3 values were exactly the same, we would have 2's here and it will pick up at 5 going on from there. So that's all the rank does. It'll group numbers that are exactly the same within the same rank and then skip however many numbers and then move on to the next one like that. Dense rank, however, doesn't skip any numbers. As you can see, these are grouped the same here in 2, but then it moves on to 3. So no matter how many values you have grouped under 2, you can have as many as you want, the next one along will be 3. So that's the only difference between rank and dense rank. Now the great thing about the rank and the dense rank is if you are designing some sort of report where you only want to show the top 10 best extended price or the lowest extended price, you can simply wrap this block of code here within another select statement. We can say top 10 star from as A, for example, and it'll only select the top 10 from there. So in this case, because we're looking at the lowest extended prices here, ranked from lowest to highest, we're going to pull the top 10 lowest customer IDs that have the lowest invoice extended prices here. So there you go, we're only getting 10 results. Here's our rank from 1 to 10. Obviously if we did it on dense rank instead, we've still got 10 rows there, and that only goes up to 9. Now we can also do it in a slightly more efficient way, where we can say where A dot rank is less than or equal to 10. That's a little bit more efficient. There you go, exactly the same result. But when we're doing the dense rank, we'll end up with a slightly different result there. There we go, 11 rows, because we're selecting all the dense ranks of 10 and below. So that's just a quick and easy way to get a top 10 or a bottom 10, etc. And it's done by the rank and the dense rank function there. So if you need to send off a set of data where they're asking for the top 10 of something or the bottom 10, you know exactly how to go about doing that. So let's have a look at another little scenario here. Sales director is keen to head up a marketing proposal for the next year, but he needs the top 10 customers from 2015. You need to write a query to give him a list of these top 10 customers with their total order amounts who ordered in 2015. Fancy giving that a try? If so, pause the video, and when you're ready, we'll have a look at the answer from my perspective. Right then, what are we looking for? We need top 10 customers. So let's pull our customers out from the database tables, and it's the sales customers. There we go. And he wants to see the total order amounts who ordered in 2015. So we're going to bring in the orders, as we've done many times before. Customer ID. And we're going to join that once again to our order lines, because that has our quantities in it. Order ID, so we've got those linked up. So what do we need to do? Let's get that filter in before we forget it. I'll put it in the where clause. Order date equals 2015, and we'll get the function in. Here we go. Brilliant stuff then. So what are we after? What columns are we after? We're after the customer name on there, and we're after the total order amounts. Alrighty then, let's get that from the lines table. And we're looking at the quantity. There we go. And we're after the total amount per customer, so we'll just sum that. I'm going to call that total orders. And then not forgetting our group by. We all know how easy it is to forget that one. Group by customer and name. So we'll run that off quickly, see how that works. So there we have it. Quite a lot of customers leading in there. Here's their total orders, variety of different numbers. So we want to do a top 10 based on these total orders here. From 2015, we've got our filter, we've got our group by. So how are we going to do that? Let's put in a ranking function then. Partition by. What do we need to partition it by? Well, we haven't got much to choose from here, so we're going to partition it by the customer name, order by the sum quantity. In fact, as we know from previous examples, we don't even need the partitioning in this case, because we're already grouping by the customer name. So we don't even need the partition in there. We're simply ranking on the sum of the quantity there on those total orders. So that makes our lives even easier there. And we're going to call that row number. So let's have a look at that quickly. See how that works out. So there's our customers, and we're looking at lowest to highest, so we need to change that round, descending, if we want the highest. Top 10 customers, so we want the highest to the lowest. So there we go, there's our top 10. Now we could of course send this to him, and he can just grab these 10 here. Let's change that to rank instead of row number. But he just wants the top 10. So what we'll do is we'll write another select statement. Within that, surround it. Less than or equal to 10. There we have it, everyone. And that's pretty much it. Pretty straightforward. He has his total orders, by far more than anyone else here, and they're just simply ranked down to 10. So that is our top 10 customers from 2015. Easily done. How did you all go with that one? Even if you wrote the individual columns here, that's all good, but I'm sure you were fine with that one, and you pretty much got those same top 10 customers. Awesome stuff then. Let's move on to N-tile, which is another cheeky ranking type function, and it's quite interesting the way it works. As you can see here, we're looking at N-tile as the function name, and we're putting a 3 within the brackets. So we're actually sending a parameter into the function itself. Now what N-tile does is it breaks the order by, what you're ordering by here, up into 3 amounts. So we're partitioning on the customer ID, and we're going to break the amounts into 3 groupings. So we're looking at thirds, and we can put N-tile 4 in there, so that will break the results into quarters. It'll effectively group the results into quarters. I know that doesn't make much sense at the moment, but we'll have a look and see how we go with that one, and I'm sure it'll all become clear when I run off the query. So let's do a few more customers, because we are partitioning by customers there, and run off that query, and I'll explain what's going on with the results. Takes a bit of time. So there we have it, customer 3, N-tile into thirds. Now you'll see with customer 3, they have 39 rows here. So 39 extended prices, ranging from the highest all the way down to the lowest, because we've got descending on our amount there. And as you can see, here it's ranked 1, because this is the highest third in the tile, as it were. And then the middle third, the middle 13 numbers, and then the bottom third, ranked, ordered by the values here. So as you can see, it's broken down all the results into thirds. Here's the highest 13, then you've got your middle 13, and then you've got your lowest 13 amounts here. As you can see, they're the lowest and going up to the highest there. Now N-tile 4, it's breaking it down into quarters. So you've got your highest quarter of these results here, and then you've got your next quarter here, then you've got your third quarter results, and then you've got your bottom quarter there. Now obviously 39 is not divisible by 4 without leaving some sort of fraction, but it does the best it can with the figures it's given to break it down into quarters as well as it can do. And that's all the end tile does, is it pretty much breaks it down into groups depending on the number you put here. And if we scroll down, we're then getting our customer ID of 4, and the same thing is happening there. We've broken it down into the top third of values, the middle third of values, and then the lower third down here. Again, in quarters for that customer ID of 4. So it can be an extremely useful function in certain scenarios. I think I've only seen it used once or twice. I haven't used it personally myself. But if you ever come across the end tile function, that is pretty much what it does. Moving on then to string aggregate. And string aggregate is quite a new function. It replaced an old set of code that you can see here. A very clunky bit of code, and you need to be quite pro to understand what's going on. And all a string aggregate does is it basically concatenates values from different rows into one single column. So for example, if we look at sales orders, if we select all the order IDs from the sales orders, you can see that they are going down into a total of 73,595 rows. But now what if we wanted to, for whatever reason, put every single order ID into one column, and one column only, so one row and one column, so effectively just the one cell. Well, we can do that with the string aggregate function. Now what we're going to do is we're going to limit the results, and we're going to say just for this order date here, so 1st of January 2016, otherwise we'll get a massive amount of data applying into one cell. So all we're doing here with the string aggregate, we're then opening it up, we've got our order ID, and we need to put some sort of a separator. So we put a comma there, and then this is our separator. So every single order ID that's shown within that cell will be separated by a comma. Now we could put a dash, we could put this for example, we could pretty much put whatever we want in there as a separator. We're going to stick with comma, and we're going to call it column order IDs. So let's execute that, and there you can see it's put everything into one cell and one cell alone, and it's also taken them in order because that's the order that they appear in the table. So if I expand that, you can see all the different order IDs from that one single date. So it's quite an interesting function. But how useful is that really? So not that much use, but if we start to bring the string aggregate as per the customer ID, so we kind of bring in a grouping as it were on the customer ID, then we can see put all the customers' orders against each customer in one row. So the row is the customer ID. We're doing the string aggregate again on the same column, the order ID. Here's our two tables. We're going to group by, and we're going to order by the customer ID. So let's have a look at that. And there you go. So we can say customer ID, and these are all his order IDs in there. Pretty straightforward. It's quite large, as you can see. Different customers will have different amount of order IDs, but so that way we can put multiple rows into one cell, and we can also bring in other columns like the customer ID. So this is pretty much treated like an aggregate function. As you can see, it's called string aggregate, and that's all it pretty much does, is it concatenates several rows just into one row there, and we include our separator. Now beforehand we used to have this bit of clunky code here, which, as you can see, we've got the len in there, we've got cast, we've got XML path, and as you can see it's just a bit crazy. We had to put in different bits and pieces to remove the final separator, final comma, etc. It really was a bit of a nightmare to put that together, whereas string aggregate is a lot more straightforward. Let's run them both off, and they return pretty much the same results as you can see there, but one is vastly easier to write than the other. So that is a little blast from the past for you. Now we can also order the values within each cell. So say for example, if we look at this one here, customer ID 1 has all the values sorted alphabetically, sorted numerically from lowest to highest, because that's how they're being pulled off the table. But what if we wanted to instead show the highest to the lowest? Well, we can simply put a within group, order by order ID, and we'll say descending, so we're going from highest to lowest in there. So must specify the within group bit, order by, and then we can crack on with that. Let's see what happens when we run that off, and there you have it. So we're getting all the same order IDs, all in one row for each customer, but we're showing the highest to the lowest. Now this function, again, it's not used all that often, but it's used enough for Microsoft to actually create it and get rid of this old clunky code there. So obviously it's got some use. I think I've used it once or twice to make sure I don't get duplicate rows on things, and it's more used to form some sort of information column. Right then, let's have a very quick look at a little example that I've got for you guys, and we'll see how you go on this one. Right, the scenario is that the product development team are looking to bring in some new products for the next season, but they need to assess what is currently in stock first. So they've asked you for the following data. You need to give them the item name, the item stock group, and the total amount of each item that's currently sitting in the warehouse. Now, as there can be several stock item groups per item, you need to find a way to pull them all into one row of data per item. So if you fancy giving that a go, then crack on, do some code, and when you're ready, we'll look at it from my perspective. Alright then, let's begin. So first things first, we need the stock item name, and that we get from the stock items. Let's bring that in, call it I, and of course we want the stock item name. So that's pretty easy to bring in. Next, we're after the stock item group. So where is that? We've got stock groups there. So let's bring that one in. We're going to call it G group, G dot stock group ID. Now you see there's no stock item ID. Let's bring that in, and you can see here there is no stock group ID. So once again, there's some sort of linking table that we need, and you've seen this before in another example. So we need the stock item stock groups. And once again, this is purely because each stock item can be in several groups, so we need the extra linking table there, like a bridge between these two tables, stock groups and stock items. We're just going to call it S. Stock item ID, stock item ID. So that one's linked together, and now we just simply link this one to the stock groups. So now we've got everything linked up. Let's bring in our stock group. Stock group name, and we've also got to bring in the total amount of each item currently in the warehouse. So we need another table there. Let's bring that in. Stock item holdings, that's what we have. And we need to link that with the stock item ID to our stock items group up there. Let's grab that there, copy and paste it down. Fantastic. And of course we need the total, so we're looking at the sum, quantity on hand. So we'll do the sum of that, make sure it's all grouped up. Total stock on hand, there you have. There you go. And of course we need to then bring that in as a grouping, because we've got the aggregate function there. So we'll group by the item name, and of course we need to group by the stock group name. Let's run that off quickly, see what we get. So we're happy that we are pulling the right columns. Clothing, we've got the stock on hand, we've got our grouping done per single item name there. So we know that our coding is working correctly. Now what we need to do is bring in the stock groups into one column, effectively replacing this, because as we're grouping a stock group name, we then get multiple columns if there are numerous stock groups for each stock item. And as we've seen with our table here, we can have multiple groups per individual item. So what are we going to do with that? Well, we're going to use the handy string aggregate function there. Let's bring that boy in there, and it's again on the stock group name, because that's what we're aggregating into one row. We're going to use the why don't we use this as a separator instead, just for fun. Doesn't matter what you've used yourself. And we can even do the within group and the order by bit. Now, doesn't matter if you've used this or not. If you've just said there's groups, for example, that's fine, and we'll get the same thing. Now we need to just remove that group by there, because this is now an aggregate function itself. So let's run that off and see what we get. And there you go, pretty straightforward and easy. And we're getting, it looks very nice, very neat, very easy to read with our slash in there. And again, it doesn't matter what separator you used, just as long as you put one in there. Now if we wanted to make sure that this is sorted alphabetically, of course we just simply add our within group bit there, and we use the same column itself. We'll just remove that descending, and we order it by that same grouping. Execute that. As you can see, everything is nicely sorted there. As we scroll down the list, you can see the extra groups popping in here and there, quite a few with this one, and all sorts down the whole list. So now we know that the product development team can easily read off that this item here belongs to these three groups, and this is how much we've got in the warehouse at this current point in time. So that's it for these window functions, and of course we threw in a little cheeky aggregate function at the end for you to look at. We covered of course the string aggregate, the end tile, which is quite interesting, and of course the rank and the dense rank. How did you all go with that one and these little examples? Pretty straightforward things, but quite fun to get your head around and put together a bit of code and get those results. That wraps up part 3, guys. We're going to go into part 4, where we're going to look at some even rarer windowed functions, but you may come across them now and again looking at some code. So we'll cover them off and we'll see what's going on with that with the final part 4. Until I see you again in that video, everyone, I hope you all have a fantastic day.